Alright, the first problem was
prove R that with R that equals.
so what you have is R vector dotted with its derivative is equal to scalar into its derivative. Okay? We have to here you need to remember d over dt of A dotted with B is equal to A dotted with d over dt of B plus B dotted with d over dt of A. Okay? This is how you take the derivative of a dot product. And similarly, derivative of a cross product. A cross B is equal to A cross with derivative of B plus d over dt of A cross with B. Okay? This is what you need to remember for derivative of dot product and cross product. So if you apply this to the first one, so where do you start? For the first one, I gave you a hint. Start at definition of dot product. Okay. One of the definitions of dot product is R dotted with R is equal to R square. This, I'm sure everybody is clear about this. And then what you do is take derivative on both sides. Okay. So you're going to get d over dt of R dotted with R is equal to d over dt of R square. Okay. So this is what you just apply this. You're going to get R dotted with R dot plus R dot dotted with R is equal to. So what is the derivative of R square? It is 2 R dot, right? Because this is a implicit function, you apply chain rule. Okay. So this, you see the dot product is commutative, which means A dot B is B dot A. Okay. So this becomes 2 R dotted with R dot is equal to 2 R dot. So this 2 cancels. So which implies R dot is equal to R.
Can you go back to explain that the derivative of R squared, you said it was the what rule?
Chain rule. So if you don't know chain rule, look up chain rule. Okay? Chain rule or implicit. This is very important. This is what you need to remember. Or this is your study guide. how to apply, and this you should know. This definition you should know. This is one of the definitions of dot product. Okay. So what is, if you go by strictly by the definition of dot product, what is it? R dot R. It's R, magnitude of R into cosine of the angle between R and R. What would be the angle between R and R?
So the angle between
Angle between R and R.
R and R.
Mm-hmm. Vector R. 0.
Okay.
Right? So if you apply the cross product, dot product definition, magnitude R into cosine of that angle. Cosine of 0 is 1.
Yeah.
So you get magnitude R into magnitude R. That is R square. Okay. What is the second one?
R equals cosine squared theta
Right. So
sine.
this is actually pretty simple. You have R is equal to cosine square theta
Yeah.
sine
Mm-hmm.
plus
Plus sine squared theta cosine.
sine square theta. Is it?
Yes. Cosine sine.
So here it's all chain rule and product rule. So here you have to remember chain rule and product rule. Okay, you need to know how to combine this or what these mean. So you have dr by dt. You're asked to take dr by dt, right? This would be equal to d by dt of cosine square theta sine psi plus d over dt of sine square theta cosine psi. Alright. So the first term, you first apply product rule. You actually have to apply both product and chain rule in both this thing. So you have cosine square theta, right? So think about this. What is the product rule? A into B, d over dt of AB is equal to A d over dt of B, right? Plus d over dt of A. This is the product rule. So if you apply this, what are you going to get? This would be, you're going to cosine square theta, okay? A is as it is. So you have to apply this for this and this. Cosine square theta, d over dt of sine theta is, sine psi is cosine psi, okay? Into d psi by dt. This is the chain rule, right? Psi and theta are functions of time. So you have to take that d psi by dt plus sine psi into derivative of cosine square theta. What is the derivative of cosine square theta? It is 2 cosine theta minus sine theta d theta by dt. Okay. So this is the first term. So let's do first. Second term will be, you have sine square theta cosine psi is minus sine psi d psi by dt plus cosine psi 2 sin theta by sin theta, and the derivative of sin theta is cosine theta d theta by. If you combine these two, you are being told to substitute d psi by dt has to be substituted with psi dot, and d theta by dt is theta dot. Okay. So the dr by dt, if you write all of it together, what you're going to get is cosine square theta cosine psi dot minus sine psi sine theta cosine theta theta dot minus sine square theta sine psi plus cosine psi So this is the complete derivative of that above function. Now, the thing with this is you won't get any partial credit for something like this. You get, if it's right throughout. If it's wrong, it's wrong. Okay?
I have a question. On these, when we were doing the derivative, in respect to what?
Time?
So, I'm saying we did these derivatives, okay, so you know how did you, what is the rule so that you know, you see how you put the d side, over dt at the end, what is that?
That is a chain rule.
That's not my question. I'm saying after you did the derivative, you did it.
So you're being told, see, this is the product rule. Okay? Chain rule. What is chain rule? Chain rule is derivative of f of g of h of t is equal to f dot of t, okay, into g dot of t into h of t, h dot. This is the chain rule, and this is what we are applying here. You see it?
Mm-hmm.
So if you think about this function for a while. So d over dt of cosine square theta. What is this? Here theta is actually h of t. Okay? Cosine theta is g of t. And cosine square is f of x.
I see where I think.
So this is how you apply the chain rule. Got it?
Mm-hmm.
What's the third one?
It was a long one. It was the one we had the 3 bedrooms.
Okay. That is actually pretty simple. I'll just leave it to you guys. It's just substitution. And the first two, especially the first two, are just substitution. Yeah, the first two are just substitution. Now, what you need to understand is, see, most of you are here. How do you calculate A dot B cross C? How do you calculate this?
Cross first.
You don't do cross first and dot. That is, you can do that, but a simpler way is to do this. A, I, or AX. We are using AX. AX, AY, AZ, BX, BY, BZ, CX, CY, C. And you take the determinant of this. This will give you A dot B cross. You replace the IJK with AX, AY, AZ.
That is easier.
Yeah, that is easier. So,
Can you come to your office and
hmm?
get them to your office and
Sure. Yeah. What I would suggest is please take a copy of your homework so that you can check this. So this, do it this way. It will be simple. Now I have asked you to use identities, right? Use identities to prove that. This one we have done. A dot B. A cross B. So this is the second one. The first one is simply substitution. It is just knowing how to take the dot product. That's it. The third one is A cross B dotted with C cross D. That's what we have. Is equal to what?
A dot with C times B dot with D.
A dot C
Yes.
Times?
B dot D
B dot D
minus A dot D times.
A dot D
Yes.
minus C.
No, times
Uh-huh.
B dot C.
B dot C. Okay. So how do you start to prove this? And you have to use back minus cab rule. Okay. Now the thing with back minus cab rule is you all of you will remember BAC minus CAB. But you have to remember this. It applies this applies for A cross B cross C. Okay. And 2, the operation between back minus cab. That is very important. It has to be this operation, this sequence of operations. If you forget the sequence of operations, if you put a dot here, it doesn't make sense. It shouldn't make sense if you put a dot here. Because what is this? What is in the parentheses? What are you going to get out of the parentheses? You're going to get a scalar component. You cannot dot a vector and a scalar. You can multiply a scalar and a vector, but you cannot dot. So the sequence of operations is important. If you do a cross, you'll go wrong. Okay? So this is something you should remember. Now, how do you apply this? What you do is you think about what you need. Okay. So let A cross B be equal to E. Alright. Then E dotted with C cross D. Now can you apply back minus cap rule for this one? Can you apply back minus cap rule for this? No, you cannot apply back cap rule. Okay? So this, what you need to do is you just need to cyclically rotate it to get it in that form. So here you can do a random rotation. Not a random rotation, but you can just say I'll move E in the middle. Okay? So what are you going to get here? D dotted with E cross C. Right? So what you're going to get here is D dotted with A cross D cross C. Okay. Now here you can apply back minus cap rule. Okay. Again, this what you need to do here is this will become minus D dotted with C cross A cross B. Right? If you apply back minus cap rule, what are you going to get? You're going to get, so this is A, B, C. It has changed. Okay. So what is B? B is A. A is C. C is B. Minus C is B. A is C. B. Alright, do you see similarities between these two? Do you see similarities?
Similarities?
Right. So look at what you are seeing here, okay? What do you want? You want A dot C, B dot D. You're not going to get that from here, but if you do, if you just think about this, I'm going to do B. I'll remove the minus sign and then say B into A dot C. I can change dot because it is commutative. So I have taken this and written it here and removed the negative sign, both on this side and this side. Okay? So minus, what do you need here? B dot C, right? You see B dot C? You're going to write A, B dot C. Now I'm going to distribute this B. Distribute this. I'm going to distribute it here and here.
You posting this, right? Dr. Sun,
Hmm?
are you posting this online?
I am recording. I won't post a solution.
But you're gonna record this.
Yeah, I'm recording the.
Uh-huh.
Alright, so once you distribute that, you have your answer. You see it? A dot C, B dot D. Right? So you're going to have B dotted with B, A dotted with C, minus B dotted with A into B dotted with C. Okay? So if you rearrange this, what are you going to get? What do you need? A dotted with C, B dotted with D, minus A dotted with D into B dotted with
You forgot to write a vector underneath that E.
Hmm?
That E.
So make sure you denote vectors appropriately. Okay? So this is the third one. What is the fourth one? What is the fourth one, Nikki?
That's the one from the first.
That's the. Let's take that for the last.
Yeah, those two are gonna go to the number 3. Is the coplanar.
All right. So let's do the coplanar. Coplanar is the sixth one.
Number 6.
Hey, can you explain to me why you went from C cross A cross B to A C I?
This is the back minus cap rule. This is back minus cap rule. You don't see it? See, back minus cap rule applies, that's what I told you. It applies for A cross B cross C. Okay? If it is A cross B cross C, it is back minus cap. So you can think about this as, see, this doesn't mean anything, it's just a nice way of remembering back minus cap. So what is A here? A is C, right? So you're going to get, what is B? B is A. A is C. C is B. So back minus cap. So this coplanar condition this is something I want you to understand, and something like this cannot be given in a study guide. Nikhil, this is something I really want you to understand. Okay? So this is where, say, if I give you a study guide, you're going to say, how do I figure out from the study guide this coplanar condition? So why is that? See, I know that condition, most of you have just looked it up on the online and given me that condition. Why that condition? Did you ever think? Did you think? Can somebody explain to me the condition? Huh? So coplanar condition for 3 vectors. Can somebody explain?
I'm gonna say you
Like,
got
there's 2 point maybe 2 lines and then get the slope of both the slope, but if you're gonna put the slope to be equal to negative 1, that is like That's exactly
But,
Right.
it's too much work.
We're not talking about
A dot B cross C equals 0. A dot B cross C equals 0.
Why?
Because when you cross two vectors, right? They create a plane, right? And so yeah, when you
How do you
B cross C is B cross C creates a vector normal to the plane.
Okay.
All right, and then so once you dot that vector with another with A, then the dot product is going to give you the projection onto. It's supposed to give you the projection onto the two vectors.
Here it is not so much about the projection. See, if you go the projection route, see, I can understand the projection route, but most of the others are not going to understand the projection route. What is a projection? What is the projection of this vector on this vector? What is the projection of this vector on this vector?
0.
It is 0. It is a point. It is actually a point. It is not 0, but it is point. But what is the dot product of these two?
0.
Why is the dot product 0?
Cosine of theta that will come with the dot product. Cosine.
Why did you understand why the dot product is 0, everyone?
You talk fast. Cosine at 90 is 0.
Right.
Anything.
So if you go by the basic definition, it is magnitude of this into cosine of angle between this. Because the angle is 90 degrees. Okay. If the dot product is 0, that means these two are perpendicular. Okay. So how does this apply to this condition? A
Was
dot.
that, I'm sorry, Dr. Sun, was that the explanation you were looking for? Just the dot product part, what you just said?
Right.
That's the reason why.
So this is, why is this the condition?
Because, yeah.
So you have to think about this. If you have B cross C, right? So let's say this is A, B, and C. Are these three vectors in the same plane?
Could be. Like a cosine condition.
Ooh, it looks to me
No,
like
it's like
C
C.
and B are the
They're
same.
the same.
All these vectors in this plane. Will this condition hold true?
X plane.
Is this condition okay? Huh?
Yeah.
Is this
If they're on the same
Huh?
plane, if they're on the same plane, then yeah.
See, these three are the vectors, okay? These three vectors are in this plane, in the board plane. Is this condition okay? Is this condition okay?
Yes.
What do you mean by the board?
What do you?
Board plane is this plane. Board is the plane. So these three vectors are on this board.
I mean, yeah.
So if you take B cross C, where is the vector going to be? The dot product.
Coming out of the board.
This,
Coming out of the board.
right? Is this vector perpendicular to A?
Yes.
So you have to think about the angle, this angle.
That's the idea. Okay.
Got it? If you take A cross C, where is the vector?
I
Still the same direction. It's still the same direction.
Huh? It's still the same, right? It is this vector. Is this vector perpendicular to B?
No.
Yes.
Any vector you take, you have to think about this angle. Is this vector perpendicular to this plane?
Yes.
If it is perpendicular to this plane, it is perpendicular to any vector in that plane.
Can you draw some vectors that are not
So if my vector is this, if it is not in the plane, you understand this is not in the plane. If this was A,
right. But when will the three that you wrote on the board not be in the plane? Or are you saying they will always be in the plane?
Say you have B.
so I cannot demonstrate that in this.
You have to use.
say I need a 3D projection. So this is what, so this is a plane, right? This is a plane. These are the three vectors we are talking about. All these three vectors are in the plane. If I do this is not in the plane. Okay. Now if I take the dot product of these red vectors, sorry, cross product of these red vectors, this one crossed with this is going to be this vector, okay, the cross product. Now this is not perpendicular to this, right? It is not perpendicular to this plane. You see that?
Yes.
So that way, now you cannot say, if you apply that condition, you'll figure out that these three vectors are not coplanar. What is the cross product of these two vectors? It will be this. This will not be perpendicular to this, because it has to be perpendicular to this, and it will be like this. You understand the condition? So you can say the cross product of any two vectors taken and take the dot product with the cross product. This condition should always apply. So projection is also right, projection route is also right, but projection route is a little difficult to understand. Here the projection route is simply because of this dot. The better way a simpler way is to just think about cosine. Cosine of the angle is, if it is 90, cosine of that angle is 0. You get it? Z? You sure?
But you said any two vectors?
Huh?
You said any two vectors perpendicular.
Any two vectors that are perpendicular,
So that you need
this, whatever is in this parentheses becomes one vector. See, the resultant or the outcome of the cross product is just another vector. The cross product of any two vectors is just another vector. Got it? So you can think about this as A cross E, B cross E, C cross E.
Oh, it's another.
C dot E, sorry. You can think about this as A dot E, B cross B dot F, C dot G.
Okay.
Got it?
Say that last part one more time.
You can think about this as A dot E,
Yeah.
or A dot D, B dot E, C dot F. Okay? So if these two have to be, the dot of this two has to be 0, these two have to be perpendicular. C dot D has to be perpendicular, that D has to be perpendicular to C.
Those are scalar triples, right?
This is a scalar triple product, yes. Why is it called a scalar triple product?
Because it's dot product.
The outcome of that is a scalar. Okay? So why is this a vector triple product?
Outcome is a vector.
Outcome of this is a vector. It will still be a vector. It will be like A crossed with D. You will get another vector. Where will this vector be? If A, B, C are in the same plane, where will this vector be?
Back in the front.
Can you ask that question one more time?
B cross C
Yeah.
will be everything, right?
Oh,
So A cross that will be, this is back in the original plane.
You sure?
B cross
Can you ask the question again?
B cross C.
Where will the resultant vector, if A, B, C are in the same plane,
Will be C.
where will the resultant vector be?
Oh, that you're saying
Perpendicular.
Yes.
Huh?
It'll be perpendicular to B.
Think about it.
Oh.
Alright, the next one. Let's do the seventh one. So this was sixth one, sorry.
So the vector, Dr. Sunny, the resultant would be where?
That's what you should answer.
Oh,
It'll be coming out of the
See, what you do is, you sit together and whatever I did, do this for yourself. Cross product, where will the vector be? Where is the cross product of this blue crossed with A up? Where is red crossed with blue? Red crossed with blue will be down. You realize that? So that's what. Then you cross with another vector. Where will that be? It depends on whether it is here or here.
Blue cross and red is up, red is down.
You see that, right? So this is, assuming this is the head and this is the tail. It also depends on where the head and tail is, okay? Okay? So it is this cross this. It has to be this. Blue cross red is this way, red cross blue is this way. It has to go down. So you do this and this.
So for that, we like it will be on the same page, but
Figure it out. I mean, I'm not asking for answer. Figure it out. Explain it to your. See, this is something you should do on your own. You shouldn't ask me to come here and. You should figure out scenarios where you're figuring out where the vector is. Because that is understanding. That is how you need to know how to apply. See, I cannot give a study guide for this. You realize this. If I give you a study guide, I'll limit you. It's like these horses they tie this blinder so that don't see anywhere else. You don't want to be horses, right?
Give it a bit of sugar and just throw it all over.
Huh? You want to be horses? Right?
Hey, James.
Huh?
Before our time,
Alright, 7 to 1. So what is given for 7 to 1?
Number 7 was the UT
Right. What is given? UT, UN, and UB.
I'm sorry.
Are these unit vectors? No? Are these unit vectors?
UC and UN are perpendicular.
Okay. So these are orthogonal vectors, okay? And these are also unit vectors. So this is the orthonormal basis. And what is the relationship? UE? What is given? UT is
UT cross with UN equals
UT cross with UN is equal to UB. And what do you need to prove?
UB cross with UT equals UN, and UN cross with UB equals UT.
Okay, I'll show you one of them. So this is given.
is that orthogonal or orthonormal?
It's orthonormal. Orthonormal means, I told you, orthogonal means just perpendicular. Orthonormal means they are unit vectors. Normalized. Normal is normalized. Normalized means unit vectors.
It means what?
Unit vectors.
Oh,
The magnitude of a normalized vector is 1. Okay? So orthonormal means unit orthogonal vector or basis. So what this means is, you have to understand what this means. If your UT is this, okay, UN is this, UB is this. So this has to be maintained, X, Y, Z. Right? Here again you have to make sure you understand that. Okay? So you need to prove that UB crossed with UT is equal to UN, right? And you need to use back minus cab rule, correct? So start with given. What is given? I'm just going to change signs for given. Is equal to UT cross with UN, right? And I'm going to UB cross with is very important. Post cross with UT on both sides. Okay. Post cross and pre cross, you understand that? The order matters. So we have to make sure we specify that. We have UB crossed with UT is equal to UT crossed with UN, sorry, crossed with UT. This has to be maintained. This parenthesis has to be maintained. Okay. So now this is equal to minus UT crossed with UN. Okay. Now change the order and use the minus sign. So you see this, I have already started with left hand side. Left hand side is already done. You see that?
Yes.
So all you need to do is now just prove that this is UN. Okay. So you see this, you can see this is as A, B, C. Apply your back minus cap rule, which is UT dotted with UN, right? Back minus cap UN UT UT. Right? And you have a minus sign. What is the dot product of UT crossed with UT and UN?
UT cross UT.
Zero.
No, dot product of UT and UN.
Zero.
Because the dot product of two, then this is zero.
2. Vectors is not 0.
Wait, oh, no? Well, not no, but
Why would dot product of 2 vectors be 0?
I have that written down somewhere, something about that.
Cosine of 90 degrees.
Right.
is used.
This is 0.
That's one.
Okay. And
Wait,
this
that's
is
what I just said.
Cosine of
What
0
happened?
is
1.
Wait a minute.
So you're going to get minus of UN, which is equal to US.
But the sun, so what happened right there? Wait, is the zero in the one part?
Yes, see, this is 0.
Right, well, why is that zero?
In the dot product of 2 orthogonal vectors, orthonormal vectors is 0. Perpendicular vectors is 0. What is given to you is this UT and UN are perpendicular, right? Orthonormal vectors. So you see, now you have proved. So similarly, you can prove the second one. You can do the second one.
And the dot product of the same vector is 1.
Dot product of same vector is not 1.
So I'm saying this little part right here.
What makes this 1?
Because it's one, it's a unit vector, they have the same magnitude.
It is unit vector and it is the same. Not it is the same vector and unit vector. That is the only time when it is 1.
Okay, so if it's the same unit vector, that would. Okay.
Can
So
you say
if
that
it was not unit vector, what would that be?
Magnitude.
That is the sort of, scalar times.
Huh? Why scalar times vector? You don't do scalar times vector. If UT was not a unit vector, what would that be?
Oh,
When
the
you
magnitude of that times the angle.
Right. So what would that be?
That means if there are two, then it's going to be. Let's say AB%.
If UT was not a unit vector, what would this quantity be?
UT squared?
UT squared.
Oh.
Okay, so the goal for this is to get like both given problems to look like each other.
So from given you have to get to this.
Okay, so then you do the same thing with the second one to get the first one. Right? Like you did, so the UT cross UN equals UB, and you want to get UB crossing T for units, and then you can do the same thing.
So you have to look at what you need.
Needs, right?
If you look at this, now for second one, what are you going to do?
Well, this year.
You already have, you need to cross every T.
See, the second one is you have to change the order. Okay, so A cross B cross C. See, if this,
Second one,
huh?
this one we did it, second one.
So you need to start somewhere. Where are you going to start for the second one?
For second one, we instead of doing first cross, we do pre-cross, and then
You get the other side.
This one.
oh,
What is the second one?
second one different side. So
The second one is,
What do you have to prove?
well, whatever we did, just prove.
Huh?
We still need to prove. There's two conditions here. You just proved that you being times T, so yeah, you need to.
U n times u b equals u t.
It is not times, okay?
I'm cross, sir.
So 4 and 5 are not going to be in the test.
Hmm?
4 and 5 are not going to be in the test, right? No, this is not test. Okay,
Just tell the truth.
they gave you the answer.
Now you're proving. You said it easy.
So this is the second one. You have to prove this. How are you going to prove that?
Just pre-cross the first with u n.
So also basically do the same, so we cross that with UN instead of UC like.
So that's not given what you just
Huh?
wrote. That's not the given information that you just wrote.
Given information is this. Given information is only this.
Okay.
So how do you get there?
Oh,
Cross with UN.
Crop, yeah.
Both y'all.
Cross with the UN.
yeah, cross it in.
Cross with UN, right? So if you cross with UN on both sides, you're going to get the right hand side, the left hand side. Okay? All you have to do is you have to prove this is equal to UT. Alright, the textbook problem, there are two problems in the textbook. I'll do one of them. The second one, we'll do it at later. Okay? So this first one, the one which is easier is
Oh, oh, the two.
so let's look at the projection. Let's look at the projection problem, which, what does it say, the projection problem? You have three vectors, right? You have A and you have B. You guys have to be somewhere, you guys have classes now?
I have a meeting coming up, but can you make this?
Yeah, let's just do this and you can discuss.
This is number 4 or 5, that's it. Dr. Sunday?
Huh?
Is this number 4 or 5?
This is
1.3 or 1.4?
So,
1.3.
Okay, thank you.
1.3.
Okay.
Okay.
So number 4 on the worksheet.
Mhm. So what is given is you have vector A. You're given vector A. Look up the textbook. The textbook figure is more visual, more clear.
Page 53.
What figure?
There's only one figure. There's no
Alright, so this is visible. So this is a problem. Okay, so you have three vectors A, B, and C. Are A, B, and C coplanar?
Yes. No.
No, they're not.
Oh, not C. I was gonna say B.
Two vectors are always coplanar. You see that?
Yes.
Repeat that one more time.
Two vectors, any two vectors, always form a plane. Are B and C coplanar?
Yes.
John Lewis, what did I say?
What two vectors are always coupled?
Okay, what do you say? Yes.
So yes, we can see it coupled.
Okay. Are C and A coplanar?
Yes.
You cannot disobey like this, John Lewis, being an ROTC.
So you can't disobey it. Oh. I'll try not to.
So you see A, B, and C, right? So what you're asked to do is the given, you're only given A, B, and C. Okay? You're required to find
CAB.
CAB. Now you have to be very careful what that CAB is. What kind of quantity is that? That's a scalar quantity you have been asked. Okay? This is a vector. Now what you're going to do is, in this, what can you find from the given information? Can you directly find CAB? Can you find vector CAB? Can you find vector CN? So what you need to understand here is, again, this is something which you have to think, and you have to make it a habit to think. As engineers, you're really paid to think. If you cannot think, if you're just going to follow instructions, you'll not get a high pay. You'll not advance in your career. If you think and if you can tell people, then you get paid higher. Okay, you'll advance, you'll progress in your career. If you take A cross, see what is UN? UN is simply A cross B divided by A cross B. So this should make sense to you. A cross B has to be that vector, right? Vector in that vector perpendicular to the plane of AB. Right? And why do we do this?
Is this
If I did not have this, it would simply be,
a vector in that direction? It would be a unit.
it wouldn't be a unit vector. When I do this cap, I have to divide that by the magnitude of A. Only then I'm going to get the unit vector. Okay? You see it? Now once you have UN, now recall projection.
CN.
Okay? C dotted with UN will give you Cn. It is the projection of, so projection of C on UN will give you Cn. But that is not the vector. This is the scalar. How are you going to get, see, this is a simple question and I can ask you in the exam. Find, so those who are attending, if I say find Cn, how are you going to find Cn?
By the first product.
Written? Alex?
You just need to know the direction, right?
No, Cn. This is not a unit vector, Cn, vector Cn. See, you do the projection, you get the magnitude.
Yeah, you have the magnitude, so you need the direction.
Right.
So
You're right, you're getting there. Right. So,
it's in the same direction as the UN.
right?
So
You just multiply by that.
multiply by
C
UN.
by
Okay.
So Cn
UN's a unit.
is simply Cn into UN. Got it?
Oh, because
It is like this. You write this A is equal to Ax I
yeah, so
plus
essentially it was
AY
So back to it.
J plus AZK, right? You remember this notation. So what does this mean? This itself is a vector in the I direction. Got it?
Yeah.
So here Cn is simply Cn into, you know the magnitude of that, what is the projection? And if you multiply that by the vector Un, you are going to get Cn. So if I'm asked, if I ask you this question, it shouldn't perplex you. Okay? Un, you know Un would be a vector. You already have that Un. So you multiply each component by this magnitude. Got it?
Would that Cn just be C? Or no, we have C times the unit vector U equals C.
It is not times.
Got
Vector C dotted with Un. Vector Un is Cn.
it. Gives us the magnitude of C.
Right.
Okay. Okay.
Okay. Now you use what is given hint. You use the hint. Okay. Hint is C is equal to CAB square plus CN square. Right. So from this, this C square is, how do you calculate C square?
We already got
It's
this.
it's already given.
Just square it.
Square.
Now what is C square is not given.
Well, C is.
Huh?
C is given.
So how do you calculate C square?
C dash C.
Huh?
Like
Square root.
vector C dash
For
C.
each one.
Vector C.
Find
Dot
the
product.
magnitude is whatever.
See, this is the reason I'm continuously asking you. This is the third time I asked you,
You give it.
what is C square? R dot R, I told you in the first problem, is R square.
Oh, yeah.
So C dot C, you're right. C dot C is c square. Or what you do, you don't take the square root. If you skip the square root, so this component square, this component square, this component square is c square. You got it? What is that c dot c? C dot c is simply this into this, right? X into x, y into y, z into z. So if you skip the square root would be c. You get it? Parallel? If you skip the square root, it will be square. Okay, now you get c square is equal to a square plus b square. You know this, you can do ca square. Got it? Now how do we, if I ask you this question, how are you going to figure out that out?
The magnitude of C.
Vector CAB.
So, it will be the magnitude of that times the unit vector of the long AB.
Yes. So unit vector AB, how are you going to calculate?
UAB.
Cross product of U and CAB.
Huh?
Cross product of U and CAB.
Cross product of U and
And then CAB, that'll give you the unit in that plane,
Oh, this one
right? The cross product of vector.
don't go by the picture. Can you justify that CAB is cross product of, so you're saying cross product of
U and,
this and this?
well, A or B, or C.
It will not be, see, it cannot be, see, this vector has to be perpendicular to both the cross you take. You understand?
So what has to be purpose?
So,
This
A cross
CAB,
B and A cross C.
if you take this and this, it has to be perpendicular to both A and this. You understand? See, if UN is of course perpendicular to CAB, but this is not, right? A is not perpendicular to CAB. When you take the cross, it has to be perpendicular to both those. The resultant has to be perpendicular to both those vectors, correct? Alright, let's stop here, but think about how you can calculate. But this thing is simple, so expect this on the exam.
I have a question. We said don't square root it. So when we're finding c squared, watch it. We're finding the magnitude and then square the magnitude.
Why should you do that?
Why can't you do that?
You can do that.
Because I don't understand squaring the components and then getting c squared. If you square each component, then
Right, so C is what? C is simply,
and then add them together.
you have Cx square plus Cy square plus Cz square, right? So C is simply this, magnitude of vector C, right? C square is this, right?
Okay.
Just this.
So that's the reason what I was telling Karen that you just forget the square root if you want C square. Or this is also C dot C. Incidentally, it happens that is also C dot C. So you can do that way also.
We talk about, so for C in or square, how would you C in that square? Would we do the same thing that we did with C square?
No, C n is what? You get this, what you get here is a number.
Oh, yeah. So we
Square
do
that number.
square, okay.
Square that number.
C squared.
The output of this is going to be a number.
Yeah, so Stanley got, I mean, Patrick got it in a magnitude scale.
Right.
So we would square the Stanley got
You stuck on its magnitude of CAB.
Yeah, try to do that. Try to think and let me know. If you let me know, you'll get extra credit.
So,
How far CAB?
Huh?
How far?
I have to find CAB.
Then you have C squared, you got C in squared.
You write it on a piece of paper and give it to me, you'll get extra credit. For first test, you'll get extra credit. 10% of the first test, you'll get extra credit.
Right now?
Not right now. You can do it. You can do it until Thursday.
it.